Okay, so we're learning a new word. This thing here, so wait, hang on. I'm doing 16.4 number 16, where I'm supposed to integrate over this region R, the square root of x squared plus y squared d area. And the region R is 4 is smaller than x squared plus y squared is smaller than 9. Okay? The word I need to use, or the word I need to learn is for shapes like this. This is an annulus. Good. What does that look like?
Kind of like
It's a ring.
two-dimensional
Yeah,
giant.
it's like a ring.
Okay,
I know. It's a washer. Do you guys remember washers when you did those Calc 2 thing where you spun surfaces and then you like add them up or something? Yeah, this is a washer. Right, a washer's a disc with a hole punched, like a kind of non-zero radius hole punched in it, and then some kind of thickness applied, right? This sector doesn't have the thickness, right? Because that's just a two-dimensional object. Yeah, so if I think about converting this, right? So some of this I know how to convert to polar. And actually that's what they asked me to do in the problem, right? Is to convert this to polar. So to convert to polar, I know there will be two squigglies. One for the r's and one for the thetas, right? And then what's the easy bit?
That's going to be R.
Oh, that thing's R. Okay, cool. And then,
R is dr theta instead of the.
okay, so then you need an R dr d theta. Please note, there's nothing special about the R and the theta order here. Right, like you could do R d theta dr if that was better. You guys all good with that?
Could we make that R squared, or is that R part of the dA?
Yeah, you could totally make that R squared, and you'll have to when you integrate. Unless you want to try to...
chain rule this.
Yeah, remember you're going backwards, right? You're integrating, so you'd need to unchain rule this.
Oh gosh.
You could try integrating this by parts, if you wanted to. I would really recommend, though, that you just stick the R's together and use the power rule, right? Okay. The reason that I wrote it this way, though, which I think is what you're getting at, is I just want to be totally clear that this part here is that d area thing, and this guy, your square root of x squared plus y squared, that became this r here. You guys see that? So the r's came from different places. One is the function I'm talking about, and the other one compensates for the area of the base. Right? So this is a height thing, that's an area of the base thing. But it's multiplication, so yeah, stick them together. How about my intervals?
Well, we first need, we use the annulus to figure out what our R is, and for d theta we know that's from 0 to 2 pi since it's a full circle.
Yeah.
You guys with him on that? So you could just take this thing, right, and convert it to polar. So converting that to polar looks like 4 is smaller than r squared is smaller than 9. And then you can do this really trippy thing where you square root the whole thing.
Oh, God.
And okay, so I get 2 and an r and a 3. And then what should you be worried about?
Positives and negatives. Plus minus.
Nah. Skip the plus and minuses because Manya's right about conventions. R should be positive, right?
It actually wouldn't really change.
Yeah, I
the
know.
result of-
Quiet. But what should I actually be worried about here?
Make sure the endpoints are included. Right?
Nah. What should I actually be worried about? You just square rooted 3 sides of a inequality, right?
Yeah.
Does that
making
flip
sure-
the order or not?
No, because
Doesn't.
they're equal to. They're equal to 4, and it's also equal to 9.
Well, I don't think that's the problem.
Yeah, so you need the equals. I'm definitely with that. But do they go the other way now? Remember that happens sometimes with
No,
inequality.
because there were no change of signs.
And equal signs are.
Yeah, so an equal sign can't flip around, right?
Yeah.
But these things can. You guys want an example?
It would just like only if the two can be sign changed.
We had no sign change, so we don't have to, correct? We don't change it.
Well, how could it be?
No, so we lied to you a long time ago in Algebra 2 when I told you that as long as you don't multiply by a negative number, you're fine. It'll stay pointed the same direction. That's actually as long as you apply an increasing function to the whole thing, the inequality order stays the same. If you apply a decreasing function, it switches order.
Does that have anything to do with?
Please notice this is an increasing function.
Right. Okay.
What do you mean how?
Or no, I see, I visualized the graph.
Increasing.
I figured you put something into that, it got smaller.
It does, but, right? Like things in general, when you square root them, get smaller somehow.
But it's still increasing.
But it's still increasing. Like if you subtract 1 from all sides of an equation, right? Or all sides of an inequality, that's applying an increasing function. The increasing function is x minus 1, right? Which is a line with slope, positive slope. Okay, see that? If you apply a function with decreasing, like minus x, say, then you have to switch the order. Okay, see that? Or if you negative logged everything, right?
That's what they still like test we have.
Okay, anyway, point is, solve that somehow. Notice the radii are between 0 and, or between 2 and 3. And then what?
We now have our lower bound and upper bound for R.
Yeah, slap those into your R bounds. So your R bounds go from 2 to 3. And where do your thetas live?
These are too high, right?
Okay. 0 to 2 pi. Yes? Why not 0 to 4 pi?
That'd be 2 circles, that would get twice the.
You guys recognize the problem there?
Double the volume.
That would cover this thing twice, right? The important thing is that you cover it once. You guys with me on that? So you could do your bounds here, your radii, could go from -2 to -3.
And it makes
As long as your angles still go between 0 and 2 pi, you'll be okay. You guys see that? You just cover the thing backwards, right? But backwards doesn't matter in areas.
So the 0 to 2 pi is because it's a circular object, right?
Yeah, the 0 to 2 pi is because there's no restriction in this annulus on my
It's just beginning.
thetas, right? And so I need to cover this thing once. This is a right, you just got to cover this sucker once. So your radii need to start at 2 and go to 3, and then you need to sweep around it. There are, of course, other ways to do this. Like your radii could go from 2 to 3, and then you could start your angle at -pi/2, right? And wrap to
Or negative.
3pi/2. If you do from -pi/2 to -pi/2, you'll get nothing. Because you won't have gone anywhere, right? Because you'll have gone to here and then stayed. You guys see that? So you just got to get it covered once. It doesn't really matter how that happens.
So if we do 2 loops, we'll double the integral.
Yeah, if you do 2 loops, so if you did from 0 to 4 pi, you'd get twice what you should get.
The density would increase.
You guys go with that?
Yep.
Could they really convey like a theta limit in XY terms, or would they just say a half angles or something like that?
Yeah, they could, of course, convey some theta limits. So something that would have theta limits in it would be like if we did a similar thing, but without the square on the y. Like say you wrote this down wrong. Now this thing is a pain in the ass right? Because this doesn't convert cleanly into polar, right? This converts to, okay, so I get 4 is smaller than r squared cosine squared theta plus r sine theta smaller than 9.
That's nice.
I don't even know how to, oops, you need a theta in there, one thing. For another thing, I have no idea how to solve this at all, for anything.
Yep.
You guys see that?
Yeah.
Why? What happened? That was a shitty region to try to convert to polar.
You convert it back into rectangular and then
I probably would go back to here and be like, wait, what is that even? Because this shape doesn't make any real sense to me.
Yep.
You guys see that?
They wouldn't be able to just give you a simple constraint so you can go from 0 to times or like.
Yeah, so another thing they could do, right, is they could say, over this region, on the right half plane or something. Right, that would restrict my thetas from minus pi over 2 to pi over 2. Or on the y is bigger than 0. Right, that would restrict us from 0 to pi in the thetas. You guys cool with that? So when you do the three-dimensional ones, when we get to doing polar in 3D, there'll be these like in the first quadrant, but inside this and outside of that, and you'll have to chase all this crap down.
Yep.
Cool? But the up and down are usually controlling angles, right? So like on the right side or on the top, those are angle things. And then the radii are just whatever. Cool? Questions, Steele? It's clear as mud? Perfect.